We use our computers all day long, saving files, opening apps, deleting junk, and we really don't give it a second thought. But just beneath the surface, there's this incredible, hidden world of organization, a silent system that's constantly fighting off pure chaos. So today, we're going to pull back that curtain and meet the digital librarian that makes it all work. I mean, really think about it. You get a brand new hard drive, and it's just this giant, empty void of ones and zeros. So how in the world does it become this neat and tidy space with all your folders and files? How does the computer know where your homework ends and your favorite movie begins? Well, the answer to that is the foundation of, everything we do on a computer. All right, meet the unsung hero of this whole operation, the file system. The best way to think about it is as your computer's own master librarian. Now, the librarian doesn't actually hold the books, or in our case, the data, but it knows exactly where everything is, how it's all organized, and how to find any piece of it in a literal split second.
And here's what's so critical to understand. Without a file system, a hard drive is just a completely unusable mess of data. It's the file system that comes in and creates the rules, the structure, the map, really. It's the bridge that turns all that raw storage into a drive we can actually use.
So to manage this huge amount of space, the file system doesn't try to track every single tiny byte of data. That would be crazy slow. Instead, it groups them into these manageable chunks called clusters. And the analogy here is just perfect. A mail carrier delivers mail to a house address, right? Not to a specific person inside that house. In the same way, the computer sends data to a cluster's address, and that cluster holds a piece of your file.
But of course, not all librarians speak the same language. See, each operating system has its own favorite file system. Kind of like how different countries have totally different formats for mailing addresses. Windows, for example, usually runs on NTFS. Your Mac is probably using the modern APFS or Apple file system, and Linux often relies on something called X4. They all get the job done, but their internal rulebooks are custom-built for their home OS.
Okay, so the librarian is amazing, but it doesn't work alone. It takes all its directions from the conductor of the entire orchestra, the operating system, or OS. So, if the file system is managing the card catalog, the OS is the boss telling it which book to go find. The OS is the ultimate manager. It's juggling everything, from which program gets to use the processor, to how much RAM your web browser is allowed to hog. And, most importantly for our story today, it's the OS that makes the requests to the file system. When you click Save, you're actually telling the OS, and the OS then turns around and tells the file system, hey, find a free spot and store this data now. And that's the chain of command, right there. You, the user, give a command. The OS figures out all the logistics, and then the file system executes the low-level, nitty-gritty task of finding the right clusters on the actual physical disk. It's this beautiful, seamless partnership that makes using a computer feel so effortless. Okay, now this is where things get really, really interesting, because not all operating systems are built the same way. In fact, there are two major families, and they each have a completely different history and a different philosophy behind their design. So on one side, you've got Windows, built from the ground up by Microsoft, and on the other side, you've got the Unix-like family. This includes both macOS and Linux. Now, these two are like cousins because they both descend from the same granddaddy, the original Unix system from way back in the day. And that shared DNA is exactly why a lot of scientific software made for Linux runs so easily on a Mac, but needs special tools or workarounds to run on Windows. At their core, they just speak different languages. And speaking of that Unix-like family, one member has become this quiet powerhouse that basically runs the modern world: Linux. You might not see it on most desktop computers at the store, but it absolutely dominates almost everything else. Just let that number sink in for a second. 96.4%. That's how many of the world's top 1 million web servers are running on Linux. That means the internet you use every single day, yeah, for the most part, it is built on a Linux foundation. It's incredible. So why? What's its secret sauce? Well, first, it's open source and usually totally free. That means anyone can look at the code, change it, and share it. This has made it the #1 choice for the scientific community and for powering the world's fastest supercomputers. Plus, its command line interface is super powerful, which is perfect for the kind of automation and heavy-duty number crunching that science depends on. I mean, it's on everything from your Android phone to the biggest data centers on the planet. So what if you love your Windows PC for gaming, but you need Linux for a big science project? Do you have to buy a whole other computer? Nope, not at all. This is where we get to have some fun and basically bend the rules of reality with something called a virtual machine.
A virtual machine, or VM, is literally what it sounds like, a complete computer, but it's made entirely out of software. It lets you run an entire separate operating system, like Linux or even another copy of Windows, inside a simple window on your desktop, just like it was any other program. It's like computer inception.
And the lingo is pretty simple. Your main operating system, the one you boot up every day, that's called the host OS. The one living inside that VM window, that's the guest OS. This setup lets you run, say, Windows as your host and have Linux running right there as your guest, giving you the absolute best of both worlds, all on one machine. And you know what? It's surprisingly easy to get going. You just install a program called a hypervisor. VirtualBox is a really popular free one. That program lets you create a new virtual computer, and you get to decide how much RAM and hard drive space it has. Then you just install an operating system on it, just like you would on a real PC, and just like that, you're running two computers at once. And this really brings everything home to the main takeaway. It's not about which OS is the best. It's about which OS is the right tool for the job you need to do. When you understand how your software, your OS, and your file system all work together, you get the power to make that choice. And learning how these systems work, especially a versatile one like Linux, opens up this massive new world of powerful scientific and computing tools. So the next time you save a file, you'll know about that silent, powerful partnership making it all happen. And now that you know the rules, from file systems all the way to virtual machines, you have the power to choose your tools, combine them, and build the exact computer setup you need. The only question left is, what are you going to build?